can have a particular strength without compromising with the we can without compromising with the amount of structure or amount of material we are using for building up that structure. And then in geotechnical engineering, that is related to earth science or or the soil, there we use lot of sensors, and those intelligent algorithms help us in developing particular form of alarms, so that we can have we can have information about the things that are going on inside the earth. Then water resource management, as you know, water resource is an important part of every human being and every living being. So its management and to avoid the crisis of water, its management is required. So optimal design of water resource system, water distribution system, that is also that also requires some application of computational intelligence, so that we provide optimal amount of water to each sector. Then remote sensing, that is very important part of image recognition, that is based on these applications of remote sensing are based on image processing, and that is widely used in civil engineering. And environmental impact assessment and management, any project related to civil engineering is passed only after environmental impact assessment is made, and in that case building up different criteria and scenarios based on which we can assess what will happen in future if we construct this project or we develop this project. Then what will be the output of that? That is also based on these soft computational techniques that we have developed over the years. And then in railways, GPS system and all those things have helped us a lot. And finally, the construction machineries. Now, with the help of artificial intelligence, we have very advanced machineries which can help us not only to reduce the time taken for construction, but also the manual power requirement required for the construction of various structures and important buildings. So now we will move towards what are the commonly used computational intelligence techniques in civil engineering and other fields. So basically there are even evolutionary algorithms such as genetic algorithm, artificial immune system, differential evaluation, or multi-objective evolutionary algorithms. Then we have swarm intelligence algorithms that are based on the intelligence of insects, that is particle swarm optimization, ant colony optimization, artificial fish school algorithm, glowworm search optimization technique, then bacterial foraging algorithm, firefly algorithm, cuckoo search algorithm, and biography algorithm. Then we have fuzzy logics, where we have fuzzy sets and fuzzy interface system. Then in learning system, we have support vector machines, artificial neural network, and reinforcement learning. So now we will move toward the problem, for which we will discuss how artificial intelligence or computational intelligence can help us to find a particular solution. Before going to the problem, am I audible?
That was
yes, sir.
disturbance. Now continue, Dr.
Okay. So before going to the actual problem, I will try to relate this problem to a general daily life experience, so that people from each background can consider this problem as can understand this problem. So generally what happens, suppose we are standing on a roof and we have an overhead tank, and somebody asks us that is there enough water available inside the tank, or should I on the motor so that it is to be filled? Then what we do, we look at the depth of water inside the tank, and based on the depth we say that we require it to run the motor or we don't require to run the motor. Although the depth is not our concern, but the volume of water is required. But through the depth we know that enough sufficient volume is available, because we know that the volume is a function of depth, and we have, if we have a constant cross sectional area, or if we have a circular tank, then we can say that the volume of water available inside the tank is function of the depth or the height of water inside the tank. So in this way, we say that based on the assessment of depth, we decide whether to run the motor or not to run the motor. So this is a case of a particular family or a particular society. But if we look at the water requirement, what will happen if we look at the water requirement of a whole city, from where the water is coming? It is coming from the rivers, and there is the source of water supply in most of the cities. So in case of rivers, we have to again have the volume, how much volume is available with us, volume of water that is available to us at a particular time. Will it be sufficient to meet the requirement of the people, or is it more than enough and it will overflow and overtop the banks of the river and create a flood in the vicinity? So this is our concern. Is there sufficient water available, or the water is more than enough and it can cause floods in the area? So in this regard, measurement of volume of water available with us in the river at a particular section is of major concern for the civil engineers. And basically, in rivers, as we know, the water is not stagnant as in case of tank, it is flowing. So we discuss the volume per unit time, that is the flow rate, how much water is flowing through the river, flow rate, and that flow rate is also known as the discharge. So therefore, the accurate quantification of discharge at various time intervals, or the real time information of amount of water available or volume of water available per unit time in a river, is of utmost importance for the civil engineers. Whether it be irrigation supply system or water management system, water distribution system, all these are dependent on the amount of water available to us. And similarly, if we want to construct some hydraulic structure, suppose we are going for a hydropower plant, then the design of that hydropower plant, we are designing a irrigation system, we are designing the dams. All these require that we have a accurate estimation of amount of water that is flowing through the river at a particular time. So real-time information of this amount of water flowing through the river is very important for us. So for this, the general procedure is that we will have to go to the river section. At a particular section, we decide that here we have to measure the discharge. Suppose we require to measure the discharge at this section. Then this river cross section is not a constant, is not a regular cross section. It has many irregularities in it, and we need to measure the volume per unit time. So what we will do, we will divide this cross section into number of subsections, and then we will take the velocity for each subsection and the area. So velocity into area will give us the flow rate, that is volume per unit time flowing through that subsection. And after integrating this discharge for each subsection, we will get the total volume of water flowing through this river section per unit time. So in this way we calculate the discharge. But if we do like that, then real time update data of this river discharge, it will go on changing, the amount of water will go on changing, and we will have to perform these calculations again and again. Then it will be very tedious and costly process to maintain such a record of discharge, or that is volume per unit time for a river. So this is the example that these people are taking a particular at a particular section. They are taking the depth of water at different locations, and then they will calculate the velocity, and based on that they will calculate the discharge. So it is a very difficult process, and continuous real-time data from this process is very difficult to obtain. On the other hand, if we make the physical understanding of what we have done here, that in case of tank, that we are determining the depth instead of the volume. So again, the same concept was used here, that instead of measuring the volume again and again per unit time, we are relying on the water level, that we take the water level at different time intervals and try to correlate that water level with the amount of discharge or the volume flowing through the river cross section per unit time. So in that case, we have developed the relationship between the water level and the discharge flowing through the river. This is known as the discharge rating curve, or simply rating of the river. So in that case, what we will do, we will have a mechanism. Such mechanisms are developed where water level of the river is continuously monitored through a gauging system, and this gauging system is converted into digital data, and we have a continuous output in the form of water level rather than estimating the discharge directly. So in this way, we have solved the problem to some extent, that we are relying on the water level rather than the discharge. But how accurate will be the estimate of discharge from this relationship, where G minus A is the water level and this Q is the discharge? So we have correlated it in this form: Q is equal to K into G minus A raised to power N. So the accuracy of discharge estimated from this particular equation will depend upon how perfectly this equation fits the data and how accurately we have estimated these constants. These are the constants K, A, and N. And these constants K, A, and N have their physical meaning. As you have seen in case of the tank, that the volume is a function of head, but at the same time it is related to a constant, that constant is area. So here again, this K correlates to the width of the river, this width of the river, or the entire width of the river, that is correlated with the constant K. And similarly, N represents the shape of the river. If this cross section is rectangular, then the value of N should be close to 1.5. And similarly, depending upon different shape, the value of N will be different. So based on this assumption, we develop a relation between water level and discharge. This is the water level and discharge data, and we fit a curve to this data and find the values of K, A, and N. So conventional solution to this problem was to develop a relation between log of water level. On double log graph paper, we have water level, that is known as the stage, and the volume per unit time, that is known as the discharge. On the double log graph paper, we plot this curve, and if these data points lie on a straight line, first of all we assume the value of A. In this relationship, we assume the value of A, and then draw a curve between log Q and log G minus A. And if the points lie on a straight line, we say that this particular value of A is correct. Otherwise, we have to repeat the calculation, or this method is entirely based on trial and error. So after number of trial and error, if we are able to fit the straight line to this curve, then the slope of this line, is this straight line, will represent the value of N, and the intercept of this line on y-axis will represent the value of log K. So in that way, we can estimate the value of K, A, and N. But this entire procedure, as a conventional procedure, is a very subjective procedure. For somebody, this line may fit like that, and this will entirely depend upon the person who is doing that, how much accurate he is calculating the value of A, and based on that value of A, we will get different values of K and N. So this entire procedure will differ from person to person, how they intercept the data, how well they fit the data. These all things will affect this type of calculation. So as an alternative to this conventional solution, as it requires a lot of trials and it involves many inaccuracies and subjectivity, that is Muzammil et al. Developed an optimization algorithm, used the optimization algorithms to develop the relationship between discharge and water level for a Lakwar Dam site in India, and we have used this optimization algorithm, that was generalized reduced gradient algorithm, for developing the relationship between water level and discharge. For this, first we have to formulate the algorithm, optimization algorithm. For that, we require some data, that is the data, observed data of water level and discharge. And based on that data, we divided the data into two parts. One is for training and other is for testing. Because if we use the entire data for training, then there may be overfitting there, and without testing the data, that whether for the data that is coming up, that is, if we are taking the data up to today, then based on that data, what will be the accuracy if we have learned the machine learning algorithm has been fed with the data till today, then will it accurately estimate the discharge tomorrow or the value that is out of that data. So for that reason, we need to calculate the data into two parts, that is the training data and testing data. And after that, we require to identify the objective function, what is our objective, then identification of decision variables, which values or which variables will affect our solution. So that has to be calculated, and based on that, we have to identify the constraints. And finally, after identifying all these three variables, we will be able to formulate the optimization algorithm. And after formulating these optimization algorithm, we can use any of the optimization algorithm to run this problem and obtain the optimal solution. So here we have the equation in the form of Q is equal to K into G minus A raised to power N. So here, what is our aim? Our aim is to obtain an accurate value of discharge Q, and we have the value of K as decision variable. K, A, and N are unknown, or the decision variables that will affect our solution, or the estimation of which will affect our solution. So in this regard, we have decided to use the minimization of sum of square of error between observed discharge values and the estimated discharge values. We are estimating discharge based on this relationship. So we are minimizing the error between them. Like this, we have this observed discharge and we are trying to estimate the discharge. So when the difference between these two, observed and estimated discharge, is minimum, then we will get the most accurate rating curve. So based on that, we have made the objective function as minimization of error or the difference between observed discharge and the estimated discharge, with K, A, and N as the decision variables. When this calculation was performed, it was found that the accuracy is much higher as compared to the conventional solution, and it has saved a lot of time actually that was earlier involved in the trial and error solution. But still, what we have that gradient based optimization techniques can be stuck in the local optimal solution. Suppose we have this search space, this is our search space, then there may be points of local minima within the search space, and there will be one global minimum solution. So in case we start with this initial value here at this peak, around this peak, then the algorithm will move the solution towards the direction of falling gradient. Gradient based optimization work towards the, when we are minimizing, so they work towards minimizing the decision variables. Actually what we are doing, that this is our equation, and we are with respect to the decision variable, each of the decision variable, we are taking the differential form of this equation and equating it to 0 to obtain the local minimum, to obtain the minimum solution, because at maxima or minima the slope will be 0. So we are taking the slope of this equation first with respect to k, first decision variable, then again with respect to second decision variable a, and finally with respect to the third decision variable n. After doing this, we put these all these differential equations equal to 0, so as to obtain, so as to get the equation, so as to get three equations, and we have three unknowns. We can simplify the three equations and we will get the solution of this problem, that is the values of k, a and n. But in case we are stuck with the local minima, then this algorithm will not move the solution in the direction of rising gradient. If we are starting with this initial point of k, a and n, then we will be safe, that we will land here, and the solution will not further move from this point in this direction. But however, if we start with this point, initial values of k, a and n are here, then what will happen, that once the solution will move in the direction of falling gradient, and it will go on moving, but here it will reach a zero gradient, and then there is rising gradient, so the solution will not move in this direction, so we will be stuck with the local minimum solution. So in this regard we have two options. One option is that we can have a multi-start option, that we start with multiple points. We will check with this point, with this point, with this point, all we will have number of initial points, and we will perform a trial so as to check whether the solution is improving or not improving. The other option is that we go for the global optimization techniques, which are not based on the gradient, such as genetic algorithm. Then in 2017, we worked on that genetic algorithm and found that the solution further improved on the use of genetic algorithm as compared to the generalized reduced gradient technique. But determining the optimal value of genetic algorithm is also a very hectic process, and it requires a number of variables, the mutation rate and all those things that should be pruned for the particular problem. So based on that, we can either use multi-start option that is now available in user interface of most of the gradient based algorithms, or we can use these global optimization technique. But even after, if we use these techniques, global optimization or local optimization technique, we are assuming that the state discharge relationship in all the rivers is of this form. The relationship between them is in this form, that is q is equal to k into g minus a raised to power n. However, there are number of factors in the river, that is the cross section changes, and there is weed growth, plant growth, debris is flowing in the river. Then all these lead to highly non-linear relationship between water level and discharge, and as such determine, pre-assuming such a structure that this discharge and water level will follow this structure only, may lead to very inaccurate estimation of discharge at the river. So in that regard, we further move towards the application of highly nonlinear techniques such as the artificial neural network, so that these algorithms themselves decide the structure of the relationship between them. We are not giving them any uh, structural form of relationship that this data should follow this particular form of relationship. So in this regard, few researchers have worked on ANN and found a more accurate solution with regard to the earlier optimization techniques that were used. And within the neural network, artificial neural network, there are a number of neural networks such as radial basis neural network and feed forward neural network. The work has also been done to compare these neural networks. But still, we have one problem with them, that they are black box in nature. Neural networks are black box in nature, and we don't get the explicit expression between water level and discharge. So in that case, we are again having a problem that how we can estimate the, if we require some calculation in the form of calculation like from discharge we want to calculate the water level, then how we calculate that? So we take a particular problem. Suppose we have a one gauging site, that is Garhmukteshwar. Let us say Garhmukteshwar. It is a site on Ganga River near Delhi, and this is the another gauging site. Our gauging site here at Kanpur. Suppose let us say here it is in Kanpur. So we have these two stations that are nearly 300 kilometers apart from each other. So we have one more technique that is known as the flood routing technique, that once the flood reaches Garhmukteshwar, we have people working here on the gauging site. Once they know that flood has arrived at Garhmukteshwar, they will alert through the flood warning system to the people working in Kanpur that the flood of such magnitude has reached here. Suppose at 2 p.m. they have a flood here. They will inform the people at Kanpur that flood of such magnitude, that is the discharge value they will tell, and such magnitude has arrived here. So you will face a flood of such magnitude, some value of discharge at around 1 hour from now. So based on that flood routing technique, we can estimate if there is a flood here, we can estimate the value of discharge here. But if we don't have the relationship between discharge and water level, we will not be able to calculate the water level based on the discharge value. We have got the discharge value instead of water level. From flood routing, we get the value of discharge and not the water level. So we know that the flood will arrive here at around 3 p.m. or 1 hour from the time it has reached here, but we don't know whether it will fill the channel and overflow or overtop the water the banks at Kanpur also, or will it remain within the bank? That will depend upon the relationship between discharge and water level here. But we don't have an explicit expression from which we can calculate back the water level at this location, that is Kanpur. So in that case, these type of algorithms or the neural networks will fail, that we will not have an explicit expression, and we will not be able to determine whether this water level, that the discharge that is coming to Kanpur at 3 p.m. will it cause a flood here, or will it not, will it remain within the limits and there will be no flood in the region. So in that case, we turn towards another algorithm or machine learning algorithm, that is multiple gene genetic programming. There are number of genetic programming algorithms such as genetic GP, and here one more is there, multiple gene genetic programming algorithm. And based on that, I and Niaskar developed a system in which we don't assume that the initial form of relationship between water level and discharge, initial form of water level and discharge, the relationship is not of this form. We don't give any functional form of relationship. multiple gene genetic programming algorithm will itself decide based on the data what is the nature of relationship between water level and discharge, and it will be highly non-linear and more accurate than the one estimated by optimization algorithms or the conventional solution. So based on that, we developed a relationship for this station. The relationship is highly complex. Here you can see that it has a number of terms, around 4, 5, 6, and 7 terms we have. And this relationship was developed based on multiple gene genetic programming algorithm. But the advantage of this relationship is that first it is able to capture the non-linearity of the system, as well as whenever we get an input in the form of discharge, we know the value of suppose this q2, then through some algorithms we can estimate the value of depth, that is y2, what will be the depth of water level at this station steam gauging site or this station 2. So in this way we can develop, we can use the computational intelligence technique to improve our solution and accuracy and
What happened? Am I audible?
Yes, sir.
Okay, it means that there is something wrong on the side of the expert.
Zakwan sir, we are not able to hear you.
There is a technical problem with the expert. Now he sort out the problem and he will be properly join us. Hello, Dr. Saab, am I audible? Dr. Zakwan Saab, are you getting my voice?
Zakwan sir, please unmute yourself.
Ji sir.
I think I'm not able to share the screen now.
Now you are audible, sir. Now you are audible.
Is it visible presentation?
Presentation is not visible, but you are visible.
My presentation visible?
Not at all, but you are visible.
Please share your screen. You have not shared your screen yet.
Dr. Zakwan, please share your screen.
Is my presentation visible?
No, no, not at all. डॉक्टर साहब स्क्रीन शेयर कीजिए।
हाँ नहीं, स्क्रीन का ऑप्शन नहीं आ रहा है अभी। अच्छा अब आ गया, अब आ गया, अब आ गया, अब आ गया। ठीक,
आ गया वो कह रहा ऑप्शन नहीं आ रहा था।
Is the presentation visible now?
Yes sir, yes sir.
जी हाँ, प्रेजेंटेशन दिख रहा है ना? ठीक है, ठीक। Okay, so we were here, some technical problem took place. So we were discussing that suppose we have a gauging site near Delhi in Ganga river, that is Garmukteshwar, and we have another gauging site on the same Ganga river at Kanpur. There is a distance of 300 kilometers between these two sites. And based on the flood routing system or flood warning system, whenever flood occurs at this site, Garmukteshwar, suppose it has a discharge of 5,000 meter cube per second, then immediately based on the flood routing system, we will get an information that at Kanpur about 1 hour from that time, a high discharge or flood will occur that will have some magnitude of discharge, say around 6,000 meter cube per second. And within 1 hour, this will reach here. So based on this system, if we have developed a relationship between water level and discharge based on artificial neural network, from the value of discharge, we can't calculate the value of water level. What will be the water level at Kanpur at that time when the flood reaches here? When we don't know the water level, we will be unable to decide whether at Kanpur move out of the river, that is, it will overtop the banks, or will it remain within the banks or within the limits of the banks. So based on, if we have developed a relationship based on black box nature techniques such as artificial neural network or any other black box technique, then such calculations will not be possible that from discharge we can calculate the water level. So in that case, we require an explicit expression in water level and discharge. So based on that, we have used another technique known as the multiple gene genetic programming that is very helpful to capture the non-linear relationship between water level and discharge, or not, between the variables, different variables. At the same time, it does not assume any particular form of equation that this particular these two variables will be related to each other from a particular form of equations that we have assumed in case of optimization techniques. In case of optimization techniques, we have assumed that the water level and discharge are correlated in this form: Q is equal to K into G minus A raised to power n. So in case of in such cases, then we when we go for multiple gene genetic programming, we don't assume any particular form of equation. We let the data to be fed into this system, and it itself decides what is the best form of relationship between the water level and discharge. And based on that, an explicit expression is developed between water level and discharge, such as the expression obtained here for the gauging side 2, that is water level is related to the depth of water, and that is the discharge is related to the depth of water in this form. It is highly complex relationship, but this complexity has led to a greater accuracy as compared to the optimization techniques, or even in as we compared this for a particular station, it was even better than as compared to the artificial neural network. So we have double advantage here, that one, we are not only able to capture the non-linearity of the system, but also we are getting the functional form of relationship between the water level and discharge. So in that case, if we have this form of relationship, and if we get the data of we get the information that such magnitude around 6,000 or 7,000 meter cube per second discharge will be occurring at this Kanpur gauging site within an hour, we can estimate the value of the depth of flow, what will be the depth of flow when this discharge will occur at this gauging site Kanpur. And based on that, we can find that whether this Y2 is greater than the depth of the river channel section, or is it smaller. And then we can estimate, or we can find that whether the flood will occur at this gauging site or it will not occur. So in this way, these computational techniques have helped us a lot in improving, not only in improving the solutions, that is estimation of discharge, but also in various forms like capturing the high non-linearity of the system, and identifying various form of relationships that can occur at different gauging site within a river. So in this way, we can have use these computational intelligence techniques to estimate the various variable relationship between various variables in not only in civil engineering but also in other fields of engineering. However, there is some physical background of the problem that need to be understood before using such relationships. For example, in case of multiple gene genetic programming algorithm, we have to run the algorithm number of times. There may be 100 runs or 150 runs depending upon the amount of accuracy we are looking for. We will get some relationship that will give us the values of discharge that is very close to the observed discharge. But if we don't have the physical understanding of the problem, so there may be some relationships that are giving performance indices very close to unity and very good performance indices, but they may estimate the value of discharge as negative. So whichever relationship out of the number of runs, whichever relationship is giving the negative value of discharge has to be discarded despite its accuracy, because negative value of discharge, that is volume per unit time, is not possible. Similarly, when we move towards the optimization algorithms also, here we have assumed this type of relationship and we are estimating the value of k, a and n from based on the optimization algorithm. So there can't be a negative value of k here, and similarly there can't be a negative value of n, because the water level and discharge are directly proportional, they cannot be indirectly proportional. And similarly, k represent the width of the river and width can't be negative. So such physical understanding along with the computational intelligence can help us to improve the solution and find a reasonable solution. Similarly, this value of n has something to do with the shape of the river as already discussed. So these things and even this understanding of the problem or the physical background of the problem will help us to reduce our efforts in terms of reducing our search space. What we have discussed about the constraints here. If we know that the value of k cannot be negative, then we can reduce the search space by putting the constraint on k as k is always greater than 0, and similarly n is always greater than 0. And if we have the physical map or the we have the idea of cross section. Suppose we have the idea that cross section is nearly rectangular or square in shape, then we can put the value of k of n as between 1 and 3. Then we can reduce the search space in this form, and as such our computational effort will be reduced. So these are the computational intelligence applications that we use in the field of civil engineering, and it has been highly useful to the civil engineers to estimate the different variables accurately. And not only that, even after getting this type of expression from multiple gene genetic programming, in order to reduce the number of runs, we can also optimize this relationship based on this relationship, or what will be the accurate value of these coefficients that are attached with the value of depth. We can again use the genetic generalized reduced gradient algorithm. So we have developed a relationship, we have improved this relationship based on the hybrid multi MJGP and GRG algorithm. So first we have used the multiple gene genetic algorithm to obtain such relationship, and further improve this relationship using generalized reduced gradient technique. So in that case also we have got a better result. Although the accuracy improved by 1 or 2% only, but it was better than the multiple gene genetic programming algorithm. So in case of floods, what we have, this type of rating curves are there, unlike single relationship. During the flood, when the flood arrives, then for the same water level, higher discharge is obtained, and when the flood recedes, then for the same water level, lower discharge will come. For example, if we take this water level as 883, for when the flood has just come in, then for that water level we will get a discharge of 4000 meter cube per second. When the flood is receding, then for the same value of water level we will have a discharge of 3000 meter cube per second. So such non-linearity in the system and highly complex relations between water level and discharge requires that we move towards computational intelligence techniques and apply them to obtain a better solution or estimate the discharge more accurately, so that our hydraulic structures, our water distribution system, water management system, irrigation system, all these can work efficiently. So similarly, based on the application of AI, now as we have discussed earlier that we used to measure the cross-sectional area by dividing into number of strips. Now this ADCP has been developed. So ADCP will help us to, once this instrument is used for measuring the discharge, then it has a software package with itself, and based on this tracking we can get the value accurate, more accurate value of observed discharge as compared to the earlier techniques where we have to manually estimate the water level at different locations and the uh, value of velocity at different locations. So in this way, these computational intelligence techniques and artificial intelligence techniques, soft computing techniques have helped civil engineers to improve the accuracy of different for estimating the different variables. So finally, we have concluding remarks. Certainly, there are advantages and disadvantages of all the approaches mentioned here, but all the approaches, whether they are conventional method, optimization techniques, or artificial intelligence techniques, they need to be applied with proper theoretical background of the problem, and once they are applied they can help very helpful for improving the solution accuracy of the solution, and that is like one we have calculated the discharge, and by using the computational techniques the solution goes on improving. And similarly, in other fields of engineering and sciences, social sciences, and allied branches, we can apply the computational intelligence techniques. At the same time, the policymakers, experts, and the engineers working in different departments need to be trained about the application of these techniques so that we can have an efficient system and we can use these computational intelligence techniques in uh, developing our irrigation system and all the government sectors that we are working in. These are few references. And finally, thank you for listening to my presentation. If you have any queries, you may raise the queries. If somebody has any query.
Dear participants, if you want to discuss something else, now you can discuss. Dr. Zakwan is
If you are having
among
any
us.
query, you may ask. And further, we can work together with the help of our team in the form of some people from computer science and some from civil engineering. We can work together and develop such algorithms and provide some solutions to the problem.
Najmun Nisa.
Yes, sir. Dear delegates, now it's time for tea break.
I think if there is any query, you may ask.
Anybody having any query?
जी डॉक्टर साहब
Sir, I think nobody has any question. So now it's time for tea break. The program will resume after 10 minutes.
डॉक्टर मोहित सर अस्सलाम वालेकुम
वालेकुम सलाम वालेकुम सलाम Is it okay? Hello.
yes sir now you are audible
I'm
properly sir
audible now?
yes
Okay,
sir
that's fine.
just now we are going to start okay sir
Your time I'm here.
Najmul Nisam, we have I think that we have to continue because our second resource person is among us okay
Okay, sir. Okay, sir.
okay let's start
Dear delegates, welcome again. Now it's time to call our next resource person, Dr. Muheet Ahmed Butt. He's going to deliver a talk over data science in agriculture. But before calling him, let's have a look over his biography. Dr. Muheet Ahmed is working as a scientist D in the Department of Computer Sciences, University of Kashmir, Srinagar, where he's involved in teaching and research activities for MCA, MTech, and PhD programs. He has around 22 years of experience in teaching, research, software development, and consultancy. He is a fellow of Institution of Electronics and Telecommunication Engineers. He is a life member of Indian Society of Technical Education, Computer Society of India, and other reputed organizations. He has more than 130 international publications in reputed journals and has guided many PhD scholars. His research areas of specialization is data mining and knowledge extraction. He was heading the software development projects in the University of Kashmir and has been the main architect in computerizing University of Kashmir examinations and registration processes for more than 4.5 lakh students enrolled in around more than 150 colleges at under and postgraduate level. These initiatives created job opportunities for many IT professionals in the UT of Jammu and Kashmir. He has been the founder faculty member for formulating courses curriculum for BCA, BSc IT, BTech Computer Sciences, Information Technology, MCA and MTech in Computer Science courses in Kashmir division. He has also remained as a president of Kashmir University Teachers Association from September 2017 to March 2020. Recently, he has also bagged Best Innovator Award in Jammu and Kashmir for his innovation in Kashmir arts out of 160 innovators in the year 2020. In addition to this, he has also worked on many national and international software projects. He has also provided consultancy to the state and central government in many information technology initiatives. He has also acted as a nominee of Honorable Vice Chancellor, University of Kashmir to Higher Education Department, Government of Jammu and Kashmir for formulating, coordinating, and providing consultancy for various ICT initiatives, projects taken up by Higher Education Department in education, curriculum design, research, capacity building, and infrastructure development in all the government degree colleges and universities of UT of Jammu and Kashmir, worth hundreds of crores. We welcome you, sir, in our program.
Thank you, ma'am.
Over to you, sir.
Thank you, Najmul Nisa, ma'am. I'm honored. Thank you very much. Means I will be first sharing a presentation, then if it is visible, or then we can start. Is it audible? Is it you are able to view it?
Yes, sir. It's visible.
I am audible. Okay. See, okay. Thank you very much, respected faculty members of the Baba Ghulam Shah Badshah University, and the faculty members and the students. I thank you all for inviting me in this FDP program. And today I am going to deliver some, I can say, some important things that you need to know about how these data sciences can aid in modern agriculture. See, you are seeing that in current scenario that many people are actually leaving their jobs. I have seen many of my friends who are IT professionals working in US and many other countries. When they get a sufficient amount of when they have a sufficient amount of money, what they do, they normally give up their jobs and come back to India and start doing agriculture. And normally some are doing some are totally focusing on organic, and some are doing some inorganic agriculture also. Now, talking about data sciences in modern agriculture, yes, data science has a huge role to play in modern agriculture, because normally when you see that there is a huge data around us, and everybody is having a mobile phone, everybody is having a computer system, everybody is using devices, and everybody is actually working with data. Means since morning you are watching your TV, you are watching your news, you are going to social media, checking the news, what are the new things that are coming. You put your good things on social media, and therefore there is huge, you can say, exchange of data that happens with your mobile phone only. If you just take a small analysis of how much data you are putting onto the internet, it will be not less than 100 to 200 MB every day. Now you can see there are 7 billion in the population of the world, 7.5 billion. So you can yourself see how many people will be having mobile phones, how many people will be using those mobile phones, and how much data they will be exchanging, and how much data will be will be exchanged between the devices and be available on the various servers. Therefore, when huge data is there, obviously it gives, when everything is happening online and everything is happening in an electronic manner, obviously the business houses, they are also concentrating on these data. And today we see that the people who have a lot of knowledge, have a lot of data, have a lot of information, are rich. It's like you see Google. Google has a lot of information, a lot of knowledge. Therefore, Google is rich. Same means you have a doctor at your locality. He has done DM. He has 25 years of experience, and he is treating patients. Obviously, he will be rich. He will be taking more. He'll be getting more money in this sector, and obviously he will become more. Therefore, there is a huge a domain of data sciences that actually we'll be discussing. Therefore, my lecture will be focusing on, normally I'll be focusing on what is actually data sciences, what are the various things that comprise data sciences, and what is there in data sciences that can be aided in modern agriculture, and what are the various applications of data sciences in modern agriculture. That is actually what I'm going to discuss in. Now, starting from the very beginning, that a computer is an electronic machine, and it takes input from the user, processes it, and gives the required output. Therefore, there are 4 stages. Everybody among us, we know that when this data is converted into information, we call it as a data processing. and we are using computer because it is a fast data processing device. And if you see the old devices, means some in 1950s, 1960s, then you have seen that there was an NVAC, there is electronic numerical integrator and computer, and there were many other. We also had there was a Vaxel machine that we are watching on, and then there were these floppy disks and all that. The memory was really less; it was only 1.44 MB. But the data used to be stored on the end. For every application, we used to have many floppies. I remember when I first started my engineering, that time we used to have systems, and those systems were floppy driven. There was no hard disk, and the computer used to get booted via floppy, and all the data we used to store on that floppy. Normally, when we were doing that photon samples, I remember we were having the same floppy disks. The big first it was what you call as a some KB, then it came 1.4 MB, around 2 MB, but only 1.44 MB was used in that. It was used to save store data. Then came the time of when you call the PCs and mobile phones, because when the first we started data processing, it was the data of a telephone exchange which actually was generating the bills. But what they used to do, they used to take the electronic data, convert into a sort of a digital form, and then save it into a file, and then used to generate the bills. And now we have data in the form of, we have huge data. As you can see, there is millions and billions of gigabytes. What you say, we have robobytes, we have petabytes. There are so much of data is generated every day, and for that we use what you call as storage area network, that is SAN, or we also use what you call as the data warehouse, but and what you call as we call them as data centers, and in those data centers we actually store data, and those centers are also connected with some cloud interfaces also, where the data is stored, while you have a value that is going to provide you a lot of service. Now, saying all this, after that there is a sort of, now where is the challenge? The challenge is we have data everywhere, but we don't have enough information. What do you mean by that? That means, say, when we had floods in Kashmir, I can say that we had all of data. We had all the forecasting of, say, many years, what the seasonal forecast, the seasonal data we all had, the climate data. Or when we had in Japanese also, when there was a Fukushima and there was a nuclear leak that Fukushima and they had to close it, Japanese say that we had all the information, we had all the data, but we did not have it. Therefore, to convert this data into a meaningful information has always been a big challenge for every computer analyst or computer professional or whatever you say, you were telling, that this has been always a big challenge. And once say if you have a data and you have a huge data and you are able to take the meaningful information out of data, then obviously it is it will not only aid in better decision making. It will all, in today's era, it will also give you money. You can also make money out of it. For example, say let's take an example. Say in Baba Ghulam Shah Badshah University, Cafe Coffee Day wants to open a shop. You have the Cafe Coffee Day wants to open a shop in an outlet in Baba Ghulam Shah Badshah University, and Cafe Coffee Day keeps a discount of, say, 50% to all the students who are in Baba Ghulam Shah Badshah. Now, what happens that when the students will come once, twice, thrice, but after 1 month they feel that, oh, it's very heavy to our pockets, because every teacup is around 50 to 80 rupees. We cannot afford that. Therefore, the coffee day will see that the people will start. There will be less customers will be coming to his place. Now, then what he will do? He will try, the cafe coffee day owner will try to give an options. He will try to make given options. Okay, I will make more 5%, more 10%. Again, the business is not good. Then Cafe Coffee Day will send a mail to Google, and Google will tell, okay, what I will do. My business is not flourishing. What should I do? So Google will tell him, okay, you don't do anything. I have an information of all the, say, for example, I have information about 20,000 people who have actually searched coffee on Google, and I have their email IDs, I have their addresses, I have even their present locations. And what you want me to do? You want me to send them an email? Maybe they live near, that is Rajouri and Jammu and Kashmir. They are near. They are people living nearby Rajouri. Therefore, what you want me to do? There are around say 50,000 people. Should I send them a mail that there is a coffee house has been opened in Baba Ghulam Shah Badshah University? Then what will happen? That Google will, okay, do one thing, just give me 25 paisa per or 1 rupee per email. Therefore, there are 50,000 yeah, customer 50,000 addresses. Therefore, Google will send 15,000 email, and immediately Google will earn 15,000. So when you will go, when Google will earn 50,000, 15,000, therefore, at the say if the same emails go on repeating for 30 days, that means 15 into 30. That means around 4,50,000 rupees will be earned in 1 month. Therefore, the Google will earn only the money will be earned only because Google has information, and the cafe coffee owner doesn't have it. Therefore, when you have information, obviously you are going to earn money out of it. And the things that are happening online, they are mostly 99.9% they are all commercial. There's very few things which are non-commercial. Rest all the things which are available, the services that we provide are provided online are mostly commercial services. Now, this data, what we were talking about, it can be a data stream, or it can be a, for example, the data can be in the form of text. Means like you are writing letters, then the text has a meaning, and you are sending those letters. The data can be in that form, like in English, Urdu, Hindi, Sanskrit, or any other language. Data can be also in the form of a data stream that by values. For example, you are having a GPS data that will be in the form of the coordinate positions of the geographical locations of that is longitude, attitude, and then there will be a zoom size and so many things. Therefore, when we talk of data, there are so many sources of data, and those sources of data are much bigger that we actually anticipate. For example, if you are thinking that I am looking at Facebook, I am adding a photograph to the Facebook, then maybe photograph is around 4 to 5 MB. But when your car is moving and directly the GPS data is sending and receiving the GPS data, automatically it may be more than 5 MB. Therefore, an autonomous car takes so much of data, which actually 2,666 internet users use. Now you can see how much data. And if it is a connected car, for example, Tesla or even Audi, even you have what you call as there are many cars which are actually BMW, which are actually connected cars, and those cars actually generate huge. Around they say that per day each vehicle generates around 4,000 GB. Therefore, therefore there is a flood of data. Flood of data in the sense is that means if you are seeing that what is that data, if you just sort of organize the data or segregate the data, the camera generates around 20 to 40 MB, the radar generates around 10 to 100 KB, the sonar, if there is GPS, it is KB, and obviously that is the if any Wi-Fi connectivity is there, that generates 10 to 70 Mbps per second. Therefore, if you just go through the comparative analysis of that, it says that around the if you just say the that comparison of today's iPhone and smart car, it is actually 3,300 years of iPhone usage can be generated in 1 hour. That means up to 500x iPhone usage. You can just see how much data is actually generated. Like that, you have data coming up because there are many sources of data. There is a data coming from the social media. That means Facebook is 68%. Like in Twitter, you have 32%, or you have Instagram and LinkedIn and WeChat and Tumblr and Vine. There are so many social area networks where the data is generated in the form of whether you are uploading the data or you are downloading the data. Obviously, data is getting sort of, or you are sharing the data. Obviously, the data is getting generated. And there is again one more source of data, that is the medical data. For example, you are using a Fitbit watch, or you are using an iWatch, or you are using a Samsung watch, or you are having an IoT device fitted on your body, that is what you call as there's some medical device like for any of the senses, like sense of smell, sense of touch, sense of any sense, or whether to calculate your heart rate, or you have somebody has for a device to check the blood sugar. and that device is connected with the other body devices which are on the other side. Again, it's connected to your mobile phone, and that we have heard about LAN, we have heard about MAN, we have heard about WAN. Now there is BAN, that is body data network. Therefore, the data, and that is a huge data. That is also, you say, for example, you are walking, it's telling you that you have made 11 steps. If you are sort of you are running, it says that you are running, or if you are doing any exercise, it will sense that you are making some, and accordingly. And not only that, there is a laboratory result data. For example, you are going to for a blood sugar test, or you are doing cholesterol test, or KFT, LFT. Those all are medical imaging, like your X-rays. You have what you call as CT scans, and many. And not only that, there is an inpatient monitoring also. For example, you are inside an ICU, and inside an ICU, their heart rate is getting monitored, and other key say your blood pressure, your heart rate, your air pressure, or many other things, your oxygen level, that are getting monitored. That again, and there are some things which are actually caught by examination. Now again, there is a data which is coming from the Internet of Things, that you might have heard about Raspberry Pi, or you have heard about what you call as the watches or cameras, which actually have an internet connectivity, or you have a you have autonomous cars, or you have autonomous fan, or you have ACs, or you have fridges, or you have home appliances where you are using these IoT devices. Therefore, there is a huge data coming out of these IoT devices. There is a huge government data. Government data in the sense that there are government is that is the government. The main the data can be at how government works. When you move your file, the file goes from junior register to senior register. Obviously, there is a flow of data. Because I'm just moving a little faster because I have a very small time there given, and there are so many presentations, many slides which I will show. I'm just going to the first, that is the flow of work, that is flow of that's command in the government sector. That is one, that is the way of one data. Another data is you have the services that are provided by the government. Whether you want to go for licensing, you want to go for health checkups, or you want to go for you want to fill a form or go for a promotion, or you want to have a you want to open your own restaurant and you want to have a license, or you want to become a doctor, you want to have a license, you want to go a lawyer, whatever. And there are so many services provided by the government. And also the data is fetched, data is given back to the, and obviously there are and those things they say that that it is done to have a transparent structure. It's done to have an accountable structure. It is done to have what you call it, what they call as a smart governance, where S is simplicity, M is molarity, molarity. Then you have SMA, SMA. Again, that is and this what you call as molarity and responsible, and that they T is the transparency. Therefore, they call it as a smart governance. Therefore, those smart governance, again, you have huge amount of data that flows in and out of the government. That is again, we have a government data. Like that, we have a shopping data also. We have a shopping data, means you are using Amazon, you are using Flipkart, you are using Snapdeal, you are using many other shopping sites, and where you actually buy things. You see products, the choices are there, discounts are there. Therefore, there is huge amount of data that goes into those shopping sites, and huge data that comes out of these shopping sites. There is again a flow of huge data in the, and obviously like that there is agricultural data also. And when we talk of this agricultural data, the modern agricultural data, means those days, now maybe we also, obviously agricultural modification, more modernization is everywhere, but there are in states of India like Punjab, you have Himachal, or in Jammu and Kashmir also, they have started using now the the very intelligent ways of actually implementing agricultural practices. And they involve, we have huge sensors. For example, you go for a drip irrigation scheme, you have to see the humidity of the soil, and accordingly, if the humidity is more, then the drip will not work. The humidity becomes less, obviously the drip will start working. You have agricultural, means they say that they are Internet of Agricultural Things. Means we have a smart plow, we have a smart picker, we have a smart grafter, we have so many things. Obviously, there is GIS. The GIS, with Geographical Information System, will give you an overview of your land. See if there are some diseases which are infecting your crops. will give you a geographical, or we can give an aerial view. Using drones, we can catch those GIS frameworks, we can catch those GIS charts, and they will provide with this sort of this spot here or this area here of the crop has been infected this year. This crop is going well, therefore there has to be we have to actually work on this set of crops that we'll be discussing. Obviously, there is drones and obviously mobility, and those drones are actually controlled on small devices like your iPads, iPhones, um, these Android phones, and those things are being. And obviously, there's a big data concept where you have a data in a form of a structure, in a semi-structured, or an unstructured manner, and you are able to query the data and able to collect meaningful information. Now, when we talk about agricultural sort of ICT in agricultural practices, we come across three layers. Number first layer is a data lake. We call it. Means data is in the form of is we can have that the data is segregated and the data is quantified, and it is placed in a small in we can say in a logical chambers, and where you have various kind of a data, where like you have a weather, food safety data, weather data, that will be discussing later. You don't have to worry about it. And after that, there is an interface. Interface means API, that is a program you are using. These interfaces are licensed interfaces. These interfaces are implicit, these interfaces are explicit. That is, they are system defined, they are user defined, they are device defined, they are sort of, we can say, package defined. There are so many permutations and combinations of these interfaces. And these interfaces are paid, these interfaces are free. You can download those interfaces, integrate. Say, for example, you are making an application in Java, you are using Eclipse, and obviously what will happen, you can directly download the APIs for these interfaces, integrate with your Eclipse, and use the device for whatever you want to do. Therefore, there can be a food safety API that will take your food data, that will take this food safety data, weather API will take weather data, pesticide will take pesticide, fertilizer API will take that. And like that, there's a market API, there's obviously IoT API. And again, these open APIs will be providing services. These APIs are only for the programmers, for the designers, developers of these applications. But the rest of the farmers, the farmers, the interface provided to farmers is very, very simple. Because normally when we talk of smart governance, the S is actually simple. There is simplicity in the function, that the things have to be very simple. For example, say you are using a mobile phone. The mobile phone can be used by anyone, whether he or she is educated or non-educated. And when everybody has taken a mobile phone, we have not gone for any training to doing for this mobile phone. Therefore, there are farmers, there are many agricultural companies. They sell, buy agricultural products. They transform even. For example, sugar cane. There we have a sugar factory which actually transforms this sugar cane into white sugar. Therefore, this data is actually used for research institutes, also government departments also, and there are also third-party ICT too. Now, when you talk of stages of this data, you have data, and the next level is actually data is basically a collection of facts or figures. Facts means truth, and figures means actually what you can draw. And after that, you have information. Whenever this data makes meaning, it becomes information. When you have a lot of information, that becomes knowledge. And when you apply that knowledge, and that then you can say that is intelligence. And therefore, when we work with these tools, now these are the things that we have to keep in mind for actually moving towards what you call as data sciences. Now, this is the simple KDA model, which most of you know, that whenever we have a huge data coming from these devices, these agricultural devices, which we have actually discussed here, there are so much of data which is getting generated. And this data can be used for making effective decisions. This data can be used for making good predictions. This data can be used for taking certain decisions which are actually impossible to take because the data size is huge, the information size is huge, and obviously the decision to be made is again very complicated to make. It's very complex to make, and for those decisions, we actually use these KDD models. And in that, what we have it's actually knowledge discovery databases. We actually use data for actually discovering the knowledge and actually extracting the knowledge. Normally, one thing I'll tell you, dear friends, that there is no machine in the world which will actually extract knowledge. The knowledge has to be extracted independent of anything. Which you have to decide. Because after seeing the pattern, you have to actually judge what sort of knowledge is actually extracted from that data. Therefore, there is no machine, there is no algorithm which will actually extract knowledge for you. The best that you will get, you can see data patterns, and data patterns, you have to actually use those patterns for the knowledge. And how does this work? This works. Say you have a huge data. It's not a small data. It is in GBs. It can be hundreds and thousands of GB, and it can be in MBs also. So what you do, you have a huge data at your control. You select the data, small amount of data. The data of your interest has to be selected, and that data has to be pre-processed. So when we talk of pre-processing, pre-processing means you can actually you can change the form of data. For example, the data is in the string form, you can convert into numeric form. Sort of you want to do some subtle operations on the data, you can do. And after that, let's say there can be outliers. That is outliers. For example, you have a blood sugar data, or you have a temperature data, and somewhere temperature is 2000 degrees. You cannot have 2000 degree temperature. Therefore, that is an outlier. There's another thing, that there's another research which actually only focuses on outliers. We are just going with a very basic evaluation of the thing. That is the pre-processing. After that, we go for a transformation. Transformation is done. Reason being, that's very important, because once you use, for example, you use say if you talk about machine learning or AI, in machine learning we use supervised. That we'll be discussing here. That is supervised and unsupervised. If you're using any algorithm for a labeled data set in supervised learning, then obviously you have to transform that data into a form so that it is read by the algorithm. Therefore, that leads to data form. And once you go for that algorithm, any algorithm, data mining algorithm that you are using, obviously you are getting certain kind of a pattern. And those patterns are actually used, and those patterns are actually used to discover the knowledge and what you call as, or whatever you want to do. You want to go for visualization, or you want to do visualization. And in the first, if you go, there is a selected data, there's a processed data, there's a transformed data. Obviously, you have a model, and obviously then you are giving input to this model. And obviously, every time you are giving input to this model will actually become more intelligent, perform better, and give better results. Now, when you talk of data cleaning is handling of missing data, or your structure errors you are fixing. For example, sometimes what happens, there is some noise in this, now some noise is generated for 52.A5, but A is an alphabet and 5 is an envelope. Therefore, what you do, you actually take an average. If the value is totally wrong, take an average of all the values and put it there, or you directly remove it and round it to the next, whatever you want to do, the way you can do it. Now, but when the same thing is implemented in an agricultural platform, the things are a little changed. And for example, you want to go for a drip irrigation or something like that. This is an intelligent, we can use for an intelligent drip systems also. We can use have a crop. Obviously, there can be an IoT sensor, anything which will be continuously giving the information to a platform, to a software. It will be taking out data out of that, and accordingly, this data will be analyzed. That will be given to that model which you have already made by using KDD, and that model will be providing a decision based on the information provided to it, and that decision will actually provide an activation. For example, if you are using a drip irrigation and you want to have an irrigate this crop, the sensor will check whether the water content in the crop is how much is the water content. Accordingly, the sensor will be sending information to the platform, maybe after say half an hour or 1 hour or 2 hours or 3 hours, and accordingly this data will be get accumulated here, and this data will be watched by your model, and accordingly your model will be giving an output, and that output actually will decide whether the crop should be given irrigation or it should not be given irrigation. Now, these are the technologies normally which actually are used for these kinds of what you call as practices. Number one is drones. You have a blockchain. Blockchain is, you have an high security. You can have, there is only one going in and coming out, and obviously the security is more, because the more customers you have, more ledgers you have. Therefore, you have to update any of the entry. It has to be updated on the ledgers. And if you a hacker or an intruder wants to change it, he has to change all, and that is practically very much important. And the encryption level is too high. You have structured here, you have a structured, unstructured, and semi-structured data. You go for augmented reality, that is also possible. 3D printing, you have, because there are some agricultural platforms which actually use these 3D printing objects for making clothes, for making agricultural tools. They are using robots. I'll be showing you that Internet of Things, and obviously that now we come across, now this is all, and that actually gives rise to what you call as data sciences. Data sciences is nothing, it is a process, and it's not a magical process. It is actually we can say a defined, a scientific, a mathematical process, which actually is used for extracting knowledge and insights from data. And here, for using that, we use what you call as we use scientific methods. Now here you have the data science. It is actually we have data sciences for many things. For example, we can it is amalgam of societal, technological, and scientific what you call as domains. And if you would just go for uses of data sciences, it is used for obviously for better decision making. It is predictive analytics. Predictive means you are, for example, you can see that tomorrow there will be rain or there will be snow. That is predictive. You are making a prediction, and obviously you are generating a pattern. A pattern also helps in sort of taking insights from the data. Therefore, you have a data, you are extracting insights from the data, that is data analysis and processing. And when you have data science process, it is called as OCMN, and that OCMN process, OCMN process is actually you are gathering information from the source, you are cleaning the data, you are finding the significant patterns, you are constructing the models, and you are putting those models into. That is the, yeah. And obviously this is and if you really want to become a data scientist, then obviously you should have a very well analytical capability should be good, and plus you should have a good questioning capabilities. Therefore, unless or until you are not able to ask questions, you are not able to extract questions from the from any experiment, from any research, you are not able to solve those. You will not be able to solve those problems. And obviously, if you just go with the various sort of the processes, that is here you have to maintain, you have to communicate, you have to analyze, you have to process, you have to capture data. For data capturing, you have to go for data entry, or you have to have a data acquisition, means you are taking data directly from the sensor, or you have to have a signal reception, or you already have a huge data and you are extracting data from that. That comes under capture. You have to maintain data. Maintain data means you have to clean data, or you have to use a data warehouse for where you can use data marts, and data marts you can use data staging and data processing, and obviously go for data architecture. Processes means what and all you can operations that you can perform on the data, that is data mining, clustering, if it is unsupervised, classification, if it's supervised, and then data modeling. Obviously, which model of data that you are going to. Data summarization is very important. That means you are taking a small summarization of data, you are making a big data into small data. Obviously, for communication, you want to tell people that this is the inside of the data. For that, you have to have data reports. You have to say whether you want to print those data, or you want to pictorially show it, or graphically show it. That is data reporting. Data visualization again is that, and business intelligence is again the part of it. And decision making, you have to tell the end user that what are the decisions that you have taken. Before an analyze is again, that is you want to analyze the data, you have to sort of compare the data and analyze it, and whether this data is that how many classes of data you are having, whether if you want to put those classes, and whether you are getting better results, is there any noise inside the data, and what the data is sufficient enough, or it is adequate enough, or the predictions that you are going to make. Because normally when we say data analytics or data or any data sciences, it is not the algorithm that matters. Algorithm matters, but not that much. The only thing that matters is data. Therefore, if you have a good data and input, obviously you will have a very good output. But for that, your pre-processing, your data accumulation, data transformation has to be wonderful. Then only you can actually get very better results from it. Now, because the time is less, I will just skip those slides. And now, if you really want to be a data scientist, these are the skills that you need to have. Now, now we come across, that is the concept that's actually called the machine learning. when we actually go for machine learning is actually, you are actually making a machine to learn. And that is not only the machine learning, you are trying to make a machine intelligent, but only once. You are not making it twice. You are only making it once. The rest of the intelligence, over a period of time, when the machine will work and will make decisions and will work, make up with all, will operate on that machine. Over a period of time, these machines will become intelligent. That is the machine. If the machine is not becoming intelligent over a period of time, then it is not machine learning. Very clear about it. Here you can see that means you have an ordinary system, you are using a little bit of AI. Obviously, you are converting that thing in a machine learning, because machine learning is what we call as a subset of AI, and deep learning is a subset of machine learning. Now here, what you have a little bit of learning, little bit of prediction, and obviously little bit of improvements that we'll be discussing. Now here you can see artificial intelligence is, and this is the subset, and here the deep learning is the subset of it. Now, whenever we talk about machine learning, we have two important things that you should very much remember. One is called, there are three things. One is called as a supervised learning, another is called as an unsupervised learning, and third is called the reinforced learning. What is the difference between supervised and unsupervised learning? I will give a very simple example because there is a lot of confusion. The students come, we have a lot of confusion, which is supervised, which is unsupervised, which is reinforced. Supervised means where you have a supervisor. For example, you want to learn cricket. When you want to learn cricket, if you have a coach, look, for example, you have never seen cricket, you have never seen a bat, you have never seen a wicket, you have not seen it, and neither you have seen people playing cricket, and you have just heard a name cricket and you want to play cricket. Therefore, if you have a coach, the coach will tell you that this is glove, you have to wear it in the hand, this is pad, you have to put it in the legs, this is pitch, this is ball, and this is the bat, you have to play with it. There are 22 players in both the teams, 11 on one side, 11 on one side, one has to bat, one has to ball. It's like that. That is actually because because coach already has a book. He has read from that book and how to play it because he was also a player once. That is why he knows. Therefore, there is already a knowledge with him, and therefore that is called when you have a supervisor. That is supervised learning. When you don't have a supervisor, for example, I want to learn cricket, but I don't know anything. The say somebody has come and has given me a pad, wickets, bat, ball, and just they have put it on the table and okay, they are telling me play cricket. Therefore, I will see a bat, say how, what is this? I'm not able to understand. Maybe I will play with wicket and I will keep a bat as a wicket, or I don't know how to play. I will just try to play a gully danda. Therefore, this is unsupervised. For example, you have seen a PK movie, that's by Amir Khan's movie. It is again an example, a very good example of an unsupervised learning. When he comes from an outer space, he sees there's a Gandhi photo on a picture. He says that okay, this is money, but he says that okay, if the Gandhi logo is on Gandhi's picture, is Mahatma Gandhi's picture is on any of the paper, that it becomes a no. Therefore, he sees a portrait of Mahatma Gandhi, makes it down and goes to the shop and okay, please, this is also a note, try to give me that. The shop says no, it's only for the money. Therefore, what he does, he makes different clusters, and those clusters he fit that this is not money. This is again Gandhi's picture, but this is not money. Therefore, and that is actually the difference between a supervised learning and unsupervised learning. And reinforced learning is, say, for example, you are playing a video game and you are not actually you are not winning that level. Therefore, you use all the permutation and combination. But once you crack that level, next time when you play the same game, you will not face the same problems in that level. That is actually part of the reinforced. Therefore, when it's a supervised learning, obviously there is classification because we know what we have to do. But when it's under supervised learning, we have clustering. And when we have clustering, somebody else should tell us actually what we are doing. Therefore, we have recommended system, we have targeted marketing, we have customer segmentation. And this is dimensionality reduction, where you have big data. And these all are the examples of you would have. Now here, if we again go with here, the machine learning supervised classification, obviously supervised and regression, and non-supervised is clustering, and obviously there is dimensional. Now this is difference between clustering, and in clustering you can put the things in the classes. Here we have two classes, but you don't know, but in the data is not labeled. The groups that are close to each other, you just try to match them. For example, that I the next slide, and here classification means you have a labeled data set, the male and female, and you are putting males on one side and females on one side. That is actually And here, if you just go with classification, you are putting, and in the clustering, you are seeing that you are actually putting classifications. You have ducks in one side and they are other side. But in you have easily the cock and all those, they have clustered. You have taken them, segregated them. But here, what you are doing, you are taking birds on the left side, and you are seeing the pictures of those birds, and on the other side, you are taking the animals. Therefore, this is clustering, because normally we don't have a labeled data set. Now, these are the machine learning algorithms normally, which actually we use in data sciences. There's linear regression, support vector machines, principal component analysis, Gauss mission model, and these. There are many, and whenever we try to implement, we can implement them in Python. And implementing in Python is we have to use a simple rule, that is what normally we use. We use a data frame, and in data frame we use what you call as, that we'll be discussing here, not here. There's a product that normally what we do here, we actually break we use what you call as, in Python we call it as a test, train, and split. We test, train, and we take the data frame. We say, for example, there are 1,000 records in that frame. We will divide that frame by 1,000. We can have 70-30, 70 for training, 30 for testing. You have 90-10, that is 90 for training. But the best is you can also have 80-20, that is 80 for training, 20 for testing. It depends on, if you have a bigger training data, obviously, if you have lesser testing data, obviously your results can be better. But if you have, say, for example, you will take 10 for training and you take 90 for testing, maybe your results will not come that good. And what you do, you divide the data into training data and testing data, and obviously you create a model that is on a training data, and obviously you give testing data as input, because once you have a data, you also know the output of that particular data, the last cell. And once you do training and testing, then you compare the last the outputs with the derived output. So that way, if the match is there, the match is what we call as you do a lot of that error analysis. That is, how many are there? That is, you check for true positives, you check for false positives, you check for false negatives, you check for false positives. That means, say, if the last value of that experiment was 1, and again using this model you are getting the same 1, then it is true positive. If the experiment was 0 and you are also getting 0, that it was true negative. But if the experiment was 1 and you are getting 0, it is true, it is false positive. And if the experiment was 1 and you are getting 0, it is false negative. Therefore, once you are doing it, then you are putting the data into training and testing. You train it, you test it, and obviously then you give a simple input to the data and to the model, and obviously you are able to get getting results of that. And based on that, you can actually generate accuracy. And if you implement it in Python, it becomes very easy. Honestly, I'll tell you, if you take a supervised classification, all the algorithm is same. Everything you are doing, you have a Skylearn package, and you take all the things from the Skylearn package here. And honestly, I'll tell you that if you just go for one algorithm, rest of the algorithm is automatic. There is no need to normally in research we just cut paste. We don't to cut paste. Directly put that algorithm in. Now, this is actually the evaluation, and this is input data, and you use machine learning model to train, test, and then obviously you evaluate. And these are actually the 4 leading data science tools that normally you are using. That is SAS, Apple, Star, Big ML, and they are both cloud-based. They are standalone based. You can buy them anywhere. And this is the wonderful TensorFlow. If you want to go for a deep learning and all that, Matplotlib is used for say if you want to make good graphics and control that graphics. Honestly, I tell you that I have not seen a better package than a Matplotlib in Python. You get so many better results. You can have we can say the data visualization at its best you can get from Matplotlib and other things. This is much better than what you get in Excel and other things. Now, having said that, now these are the technologies that are normally we are using what you call as an agri-tech. And these are what you call as that. Now we know data science, and now we want to implement this data science in agriculture. We can implement it using Internet of Things, drones, big data, biotech, vertical farming, and robotics, automation. And these are some data science in agriculture. as digital soil mapping, crop mapping. It is just like, it is such a amazing thing. If some of you people are planning to go for research, I advise you to actually go for agriculture research. And obviously you will get a lot of funding, you will get a lot of funding also, and plus you will enjoy your research. Because normally say crop mapping is just, for example, you have a digital soil and crop mapping. It is a wonderful, what you call as a, for example, like you do a blood test or you do a diabetic test or blood sugar test, the same you do a soil test. Simple. Or you go for weather prediction. Wonderful. It's again a very bright research area in what you call as data science and agriculture. You have fertilizer recommendations. You have to make recommender systems that is that comes in unsupervised learning. And recommender systems help, they aid tremendously. Means normally if you recommender system actually recommends. For example, I have a project, we are starting a neuroacoustic research project that is going on in Cluster University. It's actually a 5 crore based project. In that, what we are doing, we are actually trying to have map that is acoustic loops for the treatment of psychiatric disorders. And that is actually where we need to have a recommender system. They will recommend you. For example, means I believe that someday there will be recommender system. Somebody wants to get married and he wants to ask a question that this is my requirement. And obviously there will be a recommender system and they will be recommending what kind of wife. For those is it is going in such a sort of you will really enjoy it. Now there is disease detection and pest management. Very nice. Even whatever you have learned in image processing, whatever you have learned in what you call as better that intelligent image processing, whatever, whether you use TensorFlow or whatever you want to use for that extraction, you can use what you call as weed detection and all that. This is GTD and pest management. And in that time, you don't have to go from crop to crop. You can have a GIS picture of that crop, and directly from top to bottom, you can take a picture and just visualize that picture, and you will see what kind of diseases and pests and what are the various diseases. That I'll show you in my other slides. Because I'm going very fast. I'm sorry for that, but there are many slides. I'll not complete my topic. Adaptation to climate change. Yes, there's a huge that they are saying the world climate is changing. After 70 years, the climate comes back to what it was at the first year. Therefore, there is a huge thing that maybe in Kashmir for next after 20 years we may not grow rice. There will be no apples. There will be no what to do. Therefore, there has to be there again has to be a recommender system. Will actually tell our farmers that you should not go for rice next year. You should go for wheat. You should go for barley. There are many other crops. Or there are, see, if you really want to go, then these are the measures that you have to take. And that is actually what we call as adaptation to the climate change. And obviously, there is an automated irrigation system, which actually I have already discussed. Now, this is fertilizer. If you want to see that, there is a fertilizer recommendation. This is the farmer. Here's a mobile phone. He will directly sort of go to the server, or he will do a soil test, or the server will already, there will be scientists, they will always have done that, the information is already there. And there will be a crop recommender system that will actually recommend in that what kind of server, that disease detection. You can just see this is a very wonderful research paper which I have read. It's actually in 2000, maybe I don't know what the year was. Now this has been this is the now see the sensors they are having. So this much of research has been done throughout the US, and that is why you are having the GIS coordinates, plus you are having the infected disease also. That will give you an overall view of the disease that has been, the particular disease that has been infected. That is the forest health. It's how much forests are protected and how are healthy forests, which are sick forests, and all that. And here also is one of the projects that is actually going on in Scotch Shalimar, where actually they are taking pictures of the leaves, and they are again building the huge data set. And I believe they are 3 million to 4 million records in that data set, where they are predicting the apple diseases, the scab, and all those they are detecting using. And there is vegetation index mapping, and there are many sensors, IoT sensors, which are there, and they actually are determined. And this is actually the sensors, and these are the graphs which actually tell you that which side of the soil is fertile, which is not fertile. There is an AI-based weed detector. You have a weeds here, and they are detecting weeds. And why you are detecting this? There will be robots. They will be taking to fetching those weeds. It's not only wheat detector. There's an apple detector. There's a tomato detector. There's a potato detector. Means there are so many detectors. I'll show you. And these are the machines, the robots actually, which actually select those weeds and take out these. And there are many. This Blue River is one of the. They are saying there's a film line company, and some are saying that there are a lot of things about this company and why it has come. But this Blue River provides a lot of robots for these crop for this automation of these crops, and they fully use data sciences and machine learning for actually detection of those crops. And these are bots, and these bots are pickers. Ideally, the potato is the bot. Only select potato. Only select this. Now, main aim actually is that the research is actually there should be no human intervention in the crops. The crop should be automatically generated. This should be the farming should be automated. Everything should be automated. Because what they believe, they say that the humans are also infected. When you touch a crop, the crop also gets infected. Therefore, to have a crop infection free, to have a crop very fertile crop, very sanitized crop, what you are saying. So these are the things that these people try to implement, and these people try to. Now, these are some crop health monitoring. This will actually monitor the happens. You are seeing the lead patches, you are seeing green patches, you are seeing blue patches. Based on these patches, they are actually aerially telling you. It's not like you are moving from, for example, you have 100 acres of land. To control that 100 acres of land is very difficult. What you do, you buy a drone, you buy the system, you take a GIS photograph, you analyze that image, and you immediately get where and all you need more fertilizers, why you need crop management, why you need soil testing, why you need to go for what you can say that what kind of crops you want to go. Maybe next year you don't go for rice because rice will over exert your the nutrients of the soil. It's not a good thing to do. Do something like that. Now these are the pictures where it's just like this is a soil testing, and here what we are doing here, we are doing soil testing and diagnosis. You can see the very simple, like you do a blood test. Blood test is directly, or you take a blood sugar test. You directly make a prick in the hand, then you take some blood and put on the top of that tester, and accordingly you can see immediately you are getting the results. This is actually a research which is conducted by IBM, and they are actually going for a soil testing. There is a soil testing module here, and based you have to take a picture of that, and accordingly that the color on that picture will actually tell you that what is the nature of the soil, what is there any defect in the soil, and if there are certain nutrients, what are the means there are around, I believe, 114 attributes that you are just getting by a drop of sand. A small, if you can say some, what you can say that 1 or 2 grams of sand on this, and automatically you can see that. And that is again a research is going on. And obviously there is a huge sort of what you can say that huge area that is for weather prediction. And when we talk of these weather predictions, we have that is the predictive modeling. For example, now last time I was in the United States, and there in Ohio, they told us that the raindrop is going to touch the surface of the earth at 4:35 p.m. And actually it happened. The raindrop touched the surface at 4:35. This is the level of accuracy. This is the level of prediction those people have, because they have a huge data. They are not leaving a single feature in the data, and they are using every feature. Therefore, more the features, more better predictions. Now, obviously, these are all weather stations, and this is actually weather prediction that you are taking from data from various sensors, because obviously you have many data sets also, but better is say you are taking in historical data, you have an present data, and obviously you are trying to take the future data and try to predict that future based on the past or historic data. And many a times, we have our gentleman here, we call him as a Sonam Lotus, and many a times he is right, but many a times he is also not right. And the reason being that something Almighty has kept in his hand, and maybe we can only predict, and we can hope that that prediction will come true or that prediction will not come true. But it's up to the Almighty to decide whether that prediction has to be made true or it doesn't have to be made. Now here, this is weather predictions. If you can see, this is again and these are weather prediction analysis, and these are the These are the bots which are actually used for vision robotics and for management for like you want to grow cabbage, you want to grow potato, or you want to grow wheat, fruits and all. These are the machines which are actually automated to do it. This is actually a spraying robot. This is actually spraying what you call as is it is seeing the humidity in the soil and then making a spray. It's like the spraying robots you have also in Kashmir. You have it Royal Springs Golf Course where you have a spraying robot, because normally when you have a golf course, you have to maintain a certain bit of moisture inside that soil. Before to ensure that moisture should come. There is a last time I have seen it once. There was some problem with that. I came and rectified that. It is a basically Italian-based software, and I don't know whether they are continuing with that. Also, that is auto spray. Automatically, the spray will go on once it will feel that moisture in the soil is little less. Now, obviously, we have this problem, and we are using these devices. And obviously, there is an adaptation to climate change. You have to generalize, and these are the AI-based, what you call as agriculture. This is the market of AI, and here we can say that these are the companies which are actually using, and they are generating huge fortune for them for doing these agriculture. And this is the these are the companies which are actually going for tracking, aerial monitoring, feeding, animal farming, and thank you very much. God bless you all. Thank you very much, Alice. Thank you very much. If you have any questions, you can please. Thank you. I made it very fast.
Thank you, Moin sir. Thank you very much to spare the time for us and share the valuable information regarding the data science application in agriculture. Okay. Now, Rajmani sir, this is the time to close the session.
Okay, sir. Thank you so much, sir. Thank you for this wonderful session. Dear delegates, here the today's session ends. We will meet tomorrow at the same time. Till then, take care. Allah Hafiz.
Feedback form, please, participant, please take the feedback form and fill it. And now it is requested to the participant, please, if anybody else want to ask any query. Now, Mohit sir is among us, then ask if any query, please.
Thank you very much. I believe that there is no there is any query you can ask.
I think that there is no query. If anybody else want to ask in future, then mail me or Mohit sir also. And
you can mail me. I can put my email ID here in the box, and you can actually want to send anything you need regarding research and all that in data sciences. I'm here to help you.
Of course, sir. Of course, best sir. Again, thank you, sir, to accept the invitation and share the valuable information.
Thank you very much. Because it is getting very late. Everybody will maybe have to go to home. But I just made it very fast. Thank you very much.
It's okay, sir. Okay, no problem. Participants, please fill the feedback form. And now we are stopping the session over here. Now we will see you tomorrow, inshallah, at 3 p.m.